Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, and welcome to today's guest lecture event. My name is Zahra, a final year medical student at the Faculty of Medicine, University of Jember, and it's both my honor and pleasure to serve you as your Master of Ceremony for this afternoon guest lecture session, Integrated Agromedicine, Bridging Occupational Health, Environmental Monitoring, and Rural Industry Safety. On behalf of the organizing committee, we are truly honored to have you present with us today. Let us begin this event by respectfully acknowledging and extending our warmest welcome to the honorable keynote speakers from Japan, Professor Mayumi Suji, MD, PhD, Professor Ichiro Higashikubo, PhD, Dr. Megumi Yamamoto, PhD, the Dean of the Faculty of Medicine, University of Jember, Dr. Ulva Elvia, the Vice Dean for Academic Affairs, Dr. Ida Srirwani Wiji Astuti, and the Vice Dean of General Affairs, Dr. Herni Fatmawati, and also the Vice Dean of Human Resources and Alumni of Medical Faculty of Jember University, Dr. Yuda Nurdian. Our distinguished guests from the National Research and Innovation Agency, or BRIN, Mr. Eka Jatmika, Mr. Wahyudi, and Mr. Muhyiddin Farid. Our moderator, Dr. Drita Ardina Rahmawati, who will be guiding us through today's session, and representative from the Health and Environmental Medical Science Cluster of Jember University, including the Faculty of Medicine, the Faculty of Dentistry, the Faculty of Public Health, the Faculty of Nursing, the Faculty of Agriculture, and the Faculty of Pharmacy. And also all committee members, supporting staff, and all participants who join us today, both online and in person. To formally begin today's event, I would like to invite everyone to stand up for the national anthem of Indonesia, Indonesia Raya, followed by the Jember University hymn. Everyone may stand up for the national anthem. Thank you. You may now be seated. Okay, next, followed by the Agromedicine hymn. Okay, next, we will proceed with the opening remarks from the Dean of the Faculty of Medicine, University of Jember, represented by the Vice Dean for Academic Affairs, Dr. Ida Sri Surani Wiji Astuti, Master of Health, Fellow of Indonesian Society of Public Health, Fellow of Online Society of Community Medicine. To Dr. Rani, time is yours.
Cek. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good day, our distinguished guest, Professor Mayumi Suchi, MD, PhD, and Professor Ichiro Higashikubo, PhD. Also, Mr. Megumi Yamamoto, PhD. Welcome back in Jember, yeah, in Indonesia. Our Honorable Vice Dean of Personnel and General Affairs, distinguished structural official of Medical Faculty, University of Jember, also lecturers of Medical Faculty and another faculty in University of Jember, and my beloved students. It is my great privilege as Vice Dean to deliver this guest lecture on a highly relevant topic, reaching occupational health, environment monitoring, and rural industry safety. Nowadays, rural industry serves as the backbone of many communities, supporting livelihoods and local economics. However, beneath these benefits lie serious challenges. Workers often lack regular health screening or adequate protective equipment. Industrial operation can degrade air, water, and soil quality, and safety measures are frequently minimal. We must prioritize worker well-being by integrating health practices into daily operation. This includes providing routine medical check-up, necessary protective gear, and establishing rapid response channel for medical treatment in case of injury or illness. Equally important is environmental monitoring. Safety in rural industries cannot be overlooked. It requires developing training programs tailored to local conditions and creating emergency response plans suited to the realities of each workplace. This endeavor cannot succeed without collaboration. The university must support this effort through research funding, curriculum development, and field partnership. By weaving together these elements, occupational health, environmental stewardship, and industrial safety, we not only uphold ethical and professional standards, but also make significant contribution to the well-being of rural communities. As future leaders, I encourage you to embrace this responsibility with curiosity, empathy, and a commitment to social impact. Collaboration is the key. The university must work hand in hand with local governments, industry stakeholders, and rural communities. Students play a central role. So, by doing, we uphold not only professional ethics, but also our responsibility for social welfare and national development. Okay, for the distinguished guests, thank you for your coming here, and sorry for the inconvenience. Good day. Konnichiwa.
Thank you once again for Dr. Rani to the opening remarks. Next, we will invite it for all the keynote speakers to go forward, and Dr. Rani for the presentation of the welcoming souvenir. Sensei, you may go forward, Sensei. And please, you may go forward, Sensei. Yes. Yes, both of you. And for the documentation team to help to capture this moment. Thank you. And next for Professor Ichiro. And for Dr. Megumi Yamamoto, PhD. And once again, for all together, Professor, so Sensei, to all together to take pictures. So, ladies and gentlemen, today guest lectures carries an important and timely theme: integrated agromedicine, bridging occupational health, environmental monitoring, and rural industry safety. This theme highlights the intersection between health, environment, and industry, especially in rural and agricultural areas. Through today's lectures, we will explore real-world research and practices that address workplace safety, environmental exposure, and public health risks. To guide us through the lecture series and discussion, we are pleased to welcome our moderator, Dr. Drita Aryadina Rahmawati, Master of Health, Fellow of Indonesian Society of Public Health, Fellow of Indonesian Society of Community Medicine. To Dr. Drita, please come forward. Okay, so we will begin by reading the curriculum vitae of Dr. Drita. For the committee, please show the curriculum vitae of Dr. Drita.
It's lost in translation. It's okay.
Okay, so Dr. Drita is a lecturer in the Faculty of Medicine, University of Jember. She holds a master's degree in health science and has a strong academic engagement in general and community medicine. Dr. Drita is actively teach clinical and public health related subjects and has contributed extensively to community health research, particularly in child nutrition, stunting prevention, and metabolic disease. Her dedication is also reflected through various publications, both nationally and internationally. So without further delay, I now hand over the session to Dr. Drita.
Okay, thank you very much, Sarah. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody. It's very nice to see you all here. Thank you very much for attending today's guest lecture. And yeah, she has introduced me. I am Dwita, and I'm very honored to be your moderator today. Okay, so we are very privileged to have a series of a lot of distinguished people today in front of me, and you have been introduced to them. And it's a great honor for me to be here to moderate this event. So I would also like to, before we begin the lecture session, I would like to extend a warm welcome from the BRIN. We have met before, Prof. Eka, then Pak Wahyudi and Pak Farid. And the distinguished guests I will introduce to you one by one, and also by reading their curriculum vitae. They have come all the way from Japan. I hope you had a nice flight. And we are here to see what we can do further in the agricultural community, because we know that the workers are always imposed or always have a high risk in occupational hazards, and I think it's our responsibility to try to find a way to minimize those risks. Okay, so without further ado, I would like to introduce the first speaker today. Let me see. So the first speaker that will be coming up today is Professor Ichiro Higashikubo, PhD, from the Department of Occupational Hygiene in the School of Health Sciences. And two of our speakers today are from the University of Occupational and Environmental Health. And Higashikubo Sensei will be presenting or introducing how Japan's measurement in working places system, highlighting how systematic surveillance helps maintain healthy and safe conditions for the workers. And as you can see from the curriculum vitae, Higashikubo Sensei is graduated from Kitasato University and obtained his PhD also from Kitasato University in 2019. And if I'm not mistaken, you are also what is that? Occupational, a certified occupational hygienist. Is that correct? Yes. So we are very honored to have you here today. And just a reminder to all the guests here that the Q&A session will be at the end of the lectures. So the three speakers will deliver their speeches, and then in the end, you can prepare your questions, and we will have a discussion session for around 30 minutes. Okay, for the first lecture, for the first speaker, please, Higashikubo, I invite you to the stage. Let's give a big round of applause for our first speaker. Please, it's very nice to have you here. You can prepare first for the display of the, hopefully from the IT, can you display the PowerPoint from Higashikubo Sensei? Okay? Okay. Yes. Are you ready? Yes. That is the, yeah. To change the slides. Okay, the time is yours.
Hello everyone. My name is Ichiro Higashikubo. I'm very happy to this opportunity today. Please let me introduce myself a little. I have 35 years of experience in working environment measurement and guidance on the prevention of exposure to hazardous substances for workers at Japan Industrial Safety and Health Association before joining University of Occupational and Environmental Health Japan. I will talk about the result for measuring work environment in Japan, as I have been seconded to factory to carry out working environment management for a long time. でいけるんよね。違う、いた。よし。Okay. The rule for indoor environment in Japan is that school, large building, and factories must have good indoor environment. Laws are made for the purpose. 綺麗だね。Indoor area where people are presently must be comfortable. The indoor working environment must not cause illness or chemical poisons in workplace where 114 chemical substances are handled, working environment measurement must be carried out regularly. In addition, a risk assessment must be carried out in advance, with handling approximately 3,000 chemical substances. The ultimate goal is to remove harmful factors from the working environment through engineering measurement and to implement measures to maintain a good environment at all times. Occupational health management is carried out through three types of management. Work environment management, work management, and health management. This is a common concept around the world. However, work environment management in Japan is quite unique. Instead of measurement the exposure concentration of workers, we measure the work area and judge the working environment management. I have written down what should be implemented as a follow-up plan. The measurement of the working environment must be systematically carried out in the flow of design, sampling, analysis, and evaluation. Ultimately, it must achieve control class 1.順番が変わってるけど戻る。はい。In this way, measurement points are set every 6 meters or less. 順番違うよこれ。Measurement B sampling will be taken at the location with the highest concentration. The sampling times for measurement B is set to 10 minutes. 順番が違うけど。This shows a drawing where the work environment measurement were conducted. 使えないんだけど。Unit work area, A sampling, B sampling, highest concentration, A sampling, average concentration. なんかすごい飛んだよ。ちょっと待っていいですか。あ、これだ。A sampling is a measurement to determine the average concentration at the unit work area. No, どうにかして。Unit work area necessary for the working environment measurement, which is defined based on the worker's activity range during working and distribution of the toxic substances. よし。すっごい飛んだんですけど、ごめんなさいね。よし。ユニットワークエリアまで戻れないね。よし、いいや、しゃあない。The A sampling concentration are statistically processed. A1 is the concentration that appeared to be the most concentration T. Specifically, the estimated concentration compressing to 5% from the highest concentration site, derived from the concentration result at the unit work area. EA2 is the concentration that is considered to be the arithmetic mean. This is a calculate formula for the first control level EA1 and second control level EA2. In this way, survey results are thus evaluated using A sampling and B sampling matrix. Control class 1 is an appropriate working environment. On the other hand, control class 3 is an inappropriate working environment. Control class 2 an evaluation that indicates there is unit works area for improvement in the management of the working environment. Once the control class 3 category is researched, a local exhaust ventilation system must be installed as soon as possible. Also, respiratory protective equipment must be fitted according to the concentration of hazardous substances. ここでいいかな? This is a photograph of the worker wearing a sampler to measure breathing zone concentration to select respiratory protect for welding operations. Selecting the appropriate protective equipment based on the result of personal exposure measurement. Select respiratory protection that meets the protective factor in this way. 駆け足になりましたが、Working environment measurement in Japan requires a control of area concentrations. If the concentration of hazardous substance is an area cannot be controlled, the next step is to control worker exposure concentrations. As a company, we think it is very unique that area concentration control has been adopted as a method that facilitates the expectation of health and safety management. 早くなっちゃいました。Thank you for your attention today. Thank you. ごめんなさい。Thank you.
Yes, thank you very much, Higashikubo Sensei, for your topic about the working measurement system in Japan. And for the audience, if you would like to ask more about what was displayed on the screen, you can jot your question down and ask in the end of the session. I think we will move on to the next topic first. So, Professor Mayumi Tsuji, MD, PhD, is from the Department of Environmental Health, School of Medicine, also from University of Occupational and Environmental Health. I would like to invite you to the stage and prepare Tsuji Sensei. And while she's preparing, I would like to furthermore tell you about the topic that she's going to be presenting. It's about the adverse health effect of welding fume in Japanese male workers. Okay, so this should be interesting because we have male welders here in Indonesia too. So Tsuji Sensei graduated from Kagoshima University, and at the moment she is the Director of Japan Environment and Children's Study at University of Occupational Environmental Health, and also the Director of Japan Environment of Children's Study at Fukuoka Center. Is that correct, Tsuji Sensei? Okay. I think we are very all interested to hear about this topic because hopefully we can get more insight. And we have you could have roughly around 30 minutes to present your topic. The time is yours.
Okay. Senang Bartanam Denam, Sena Mayumi Tsuji. Hello, it's nice to meet you. My name is Mayumi Tsuji from Japan. I'd like to thank Jember University's staff for kindly inviting me to speak here today. Oops, please change thank you very much. So before introducing my research, I would like to introduce myself. I graduated from Kagoshima University's School of Medicine. Since 2019, I have been a professor in the Department of Environmental Health School of Medicine at the University of Occupational and Environmental Health. So I studied at the UC Davis over 10 years ago. If you have the opportunity, try studying abroad. It will be a good opportunity to look at yourself. It was a good opportunity for me to realize that I like research. But I don't have any talent for language. That's why I'm reading an English manuscript today, so sorry. So I have been conducting research on two main themes now. The first is JEX study. I have been active as a member of the JEX study science since its inception. I serve on various committees. Since 2011, the Ministry of the Environment has conducted the Japan Environment and Children's Study of JEX, a large-scale nationwide epidemiological study involving 100,000 mother-child pairs living throughout Japan. JEX aims to identify the impact of environmental factors on health and development of children. It measures the environmental exposure during pregnancy and through childhood. While examining children's health periodically until they become at least 18 years of age, it was recently decided to continue the survey until the children reach the age of 40. Therefore, JEX continue until I retire the research. Continuously, operating a large cohort requires a large budget. 5 billion yen every year, this survey. Approximately 5 years after JEX began, the diet would evaluate whether it was worth continuing JEX. I was under pressure from JEX committee to have exactly 1 paper accepted before the diet committed. This paper was written by me and was the first paper published as part of JEX. This is my glorious paper, I think. Result. Pregnant woman is a group with the highest blood cadmium concentration were 1.9 times more likely to have early preterm birth compared to the group with the lowest blood cadmium concentration. Children born early preterm have a higher mortality rate than children born at term. This paper was in line with JEX's purpose, which is for the children of the future. My research theme, too, is health of workers. Today, I would like to introduce the result of an epidemiological study targeting welders that I have been conducting in recent years. As an epidemiologist, I have worked on 2 different types of research: large-scale studies and small-scale studies. Today's welders study is a small-scale study that can be carried out with a small budget and staff, and that focus on occupational areas that can have an immediate impact on protecting the health of workers. Before introducing the research on welders, I would like to explain the environment of the welder's site and home. This is a photo of a woman practicing welding. This is me. I got beginner welding license. I don't think you will be able to get an image of welding just by looking at my photo, so I'll show you video. The white smoke is fume. Fume has 2 aspects of toxicity. The first is dust. There is a risk of causing lung cancer. Second, there are adverse health effects caused by the chemicals contained in fume. Especially, manganese has been shown to affect neurological function. Previous studies have also reported that exposure to manganese in welders cause abnormalities in neurological function. Here is a measurement result of the working environment. So Professor Higashikubo showed that term. This number and that number as match. Workers other than welders also work at the site. By law, welders only wear aspirators, masks. So these concentrations is high or low. So please look at the pink circle. Take PM 2.5 as an example. The Japanese government regulated PM 2.5 as it has adverse effect on human health when the average daily concentration exceeded 35 microgram per cubic meter. United States is almost same. PM 2.5 affects respiratory diseases, cardiovascular diseases, allergies, and cancer. So what is the environment situation in Indonesia? The air in the big city is very bad. But you can see that the air around Jember is suitable for living, so good. Dark purple and red areas are polluted air area. Looking around the world, we can see that there are areas in major cities with experimentally polluted air. On this day, the air in Mumbai, India, was polluted to a level that was dangerous for people. Yeah, this is Mumbai. So, however, the concentration of hume at welding site is an order of magnitude different from the concentration of PM 2.5. Welding sites are places where very high concentrations of chemicals are present in the environment. I hope you understand that the concentration of welding fume can have a strong effect on workers' body. Then, what you might think, shouldn't efforts be made to lower the concentration of welding fumes, especially the manganese concentration, which is bad for the body? In industrial medicine, there are some methods to take when there are substances that have an adverse effect on the body to protect workers' health. Avoid using chemicals. Seal the workplace. Use exhaustive ventilation. Wear respiratory protection. Manganese is necessary as a dioxidizer to make good products and is used as a coating material for welding wire. So, splashing of manganese into the environment cannot be avoided at welding sites. Exhaust equipment cannot be used. This is because if the wind blows, holes will form in the welded parts, making it impossible to produce a good product. The use of respirators, masks, is the ultimate and last resort to protect welders from fumes. Before I listen to my research result, please remember respirators are the most important final equipment to protect human health at the welding site. So it was a long introduction. I will talk about welding site investigation. There are 3 what's new points in my research. First, participants' blood and urine were collected after work on Thursday or Friday. Why? This is the timing when chemical concentration in labor-derived biological samples are at their highest. Second, we measured the concentration of respiratory dust using a personal sampler. So this is Dr. Higashikubo sensei already explained. Welding fume is carried by the rising air of the arc and spread into the air at a considerable speed. Directly above the point of generation, the concentration is highest, exceeded 100 milligram per cubic meter, reaching at least several tens at microgram per cubic meter. Measuring breathing zone concentrations by using personal sampler can estimate the actual concentrations to which welders are exposed. Third, we conducted mask fit test. A mask fit test uses a measuring device to measure how well a mask fit by checking how much chemical substances floating in the outside air are leaking into the mask. Welders are exposed to chemicals if their masks don't fit properly. This person is wearing a mask correctly, so blue circle. The welder's mask does not fit. This is an improper mask wearing. If the welder's mask does not fit well, because he uses a mask cover and wearing an overprotected hood, so the air is into the mask. Yes. Today I would like to introduce 3 articles that have already been accepted. This paper was used What's New 3 points using biological sample, personal sampler, and the result of a mask fit test. The purpose of this first article is to clarify the following question. If welders is not properly wearing a mask and there is a high concentration of human around the face, what will be the metal concentration in the biological sample? This is a result. In the mask fit test failing group, when the concentration of respirable manganese measured using a personal sampler is high, the blood manganese concentration becomes statistically significantly higher. In other words, when welders with poor fitting mask work in areas where there is a high concentration of welding fumes in their breathing areas, the manganese concentration in their blood increases. You may take this result for granted. However, proving something obvious is surprisingly difficult in our field. This is a second article. The theme was, are there any differences in the health effect of manganese between welders and non-welders? Manganese affects the nerves. 3 tests that were associated with manganese exposure in previous studies were measured as indicators of health effect: grip strength, working memory index, and tapping. Tapping is a fingers test.
Excuse me, Suji-sensei.
Oh.
I'm sorry. I think there's a technical glitch on the screen. Can we pause the presentation for a second?
Okay.
And we will reset the screen first. Okay, from the IT department. Can you? Oh, there's one small box that wouldn't move. Okay, let's wait for the reset button to take effect. Sorry, Suji-sensei.
Yeah, no problem.
The one over here is fine, but the big screen did not display well. Okay. While waiting, can I confirm one thing? So you actually took a lesson to get the welding, what do you call it? To get the license to weld? You took a license for that, for beginners?
Yes.
Yeah.
I took.
You had to take it first
Yes.
before you can do that on the
Yes.
screen. Oh,
Before
that's
I'd
great.
like to understand welders.
Yeah, I know. All out. Okay.
Okay.
Is it already back to normal? Oh no, it's still black. There's still a black section on the board. Okay,
Oh,
patience. Hopefully the second reset will do fine. Okay. And it must have felt really hot being in front of the welding.
Of course.
Is that it's not flame, it's what do you call it? what does the welding produce? What besides the
what
fuel?
kind of
Yeah.
building?
Mm.
Oh, it's up to companies. So some companies make ships.
Oh, I see.
Some company makes the shelf.
Oh,
Yes,
for those companies.
Yeah, and what kind of material use and what kind of they are making. So the fumes type are totally different.
Different.
Yeah, it's very interesting.
It depends on what they are welding.
Yes.
Oh, I see.
Yeah. Most dangerous position is so to make shelf, they put into their head into the shelf.
Inside the shell.
Yes,
Okay.
inside shelf. So totally high concentration
High
of fume
content.
they exposed.
I see.
Yeah, so working position is very important.
I know.
Ah.
Yeah.
So I'd like to go to the factory and watch directly.
Okay. I'll try to just picture that in my mind. Okay. So I think the screen is back on. Yes.
Is it okay?
So you can continue with your presentation.
Okay, so
Fujii-sensei.
yeah, thank you. So these tests were carried out before starting work or after lunch. Before fatigue increases. This is result. There are no differences in age, smoking habits, and drinking habits. Cadmium, nickel, chrome, mangan, and lead are well-known metals found in welding fumes. In this study, cadmium, manganese, chrome, and lead concentration were higher in welders than in non-welders. I think nickel content will rise at welding site where stainless steel is used. This time, since the site uses a lot of iron, there probably was no difference in the results. Result is significant differences WMI, Working Memory Index, and blood mangan. Using statistical software, the subjects were automatically divided into 3 groups, total according to manganese concentration, low, medium, and high. This showed that the rate of worsening of WMI, Working Memory Index values, is approximately 4 times 3.73 higher in the high manganese concentration group than in the low manganese group. There are statistically significant difference only in the relationship between WMI and blood manganese in all subjects, especially welders. Looking at the result of this table, we realized that we had made a terrible mistake in designing the study. Non-welders with high blood mangan levels also tend to have low WMI. We wanted the control to be an unexposed population. However, some non-welders had high manganese levels. Control group design setting was bad. It's my mistake. However, this result led me to ask the following question. If people other than welding workers enter the factory, might they be exposed to secondary exposure to welding fume? The standard for determining that there is a high possibility of occupational exposure to blood manganese is 1.5 microgram per deciliter. When we checked, actually even among non-welders, 4% of subjects have over 1.5. These 4% of people might have secondary exposure. The study design regarding that establishment of control group was unsuccessful. However, it has become clear that we may need to pay attention to the health of workers who enter and exit a welding site too, not only welders. This is a paper introduction video created by Wiley. It was very good. Did you notice it while watching the video? Some workers were not wearing masks. Workers other than welders are not required to wear masks, even if they work near a welding site. It is outside the scope of the law. So this is the third article. The theme was, are there any differences in immunological responses between welders, non-welders in the factory, and workers working away from factory, meaning the general subjects? This is our latest paper. Some cytokines showed higher levels in non-welders in the factory than in the general subjects. In particular, inflammatory cytokine interleukin-12, TNF-alpha, representative cytokines released by microglia during neuroinflammation. Furthermore, some inflammatory cytokines, interleukin-70A, interleukin-33, even tended to be higher in non-welders. We have proven that humans have adverse effects on the bodies of non-welders working in factories without wearing masks. My next theme, how many non-welders workers in a factory should wear masks? Our research is continued. Factories that can afford to spend a huge amount of money can distribute masks widely. However, small and medium-sized businesses cannot afford it. It is important to indicate which workers should wear masks only when necessary. Otherwise, the advice we give as industrial physicians will not be accepted. Further research is currently being carried out at the factories to see if it is possible to map exposure levels at the workplace. It's my theme now. With the support of many colleagues, we are conducting research to protect the health of workers at welding sites. Today's speakers are also one of my collaborators. There is no end to the research themes. I always conduct my research with enjoyment and a spirit of inquiry. Nothing would make me happier than if my research could lead to improved health for workers. Terima kasih sudah mendengarkan. Thank you very much for your time.
Terima kasih kembali Suji Sensei. Wes balik lidah balik Jawa. Okay. Thank you very much for a very insightful topic about welders. So we know in Indonesia we have also workers ya tukang las ya kita taunya ya. And I think the more people who are concerned about all of these types of workers, I hope we can make a better and healthier community. Okay, so after the two topics, the last topic is actually about the toxicology of mercury in the environmental surroundings, and it will be presented by our last but not least, our third speaker, Dr. Megumi Yamamoto, PhD. This is your second time here in our institution. We are very, very happy to have you again. And while we scroll or display the CV of Yamamoto Sensei. Yeah, so currently Yamamoto Sensei is so we can see that Yamamoto Sensei has graduated from the School of Medical and Dental Sciences in Kagoshima, and I think we can see that from the numerous works of published research. And currently, Yamamoto Sensei is the director of the Department of Environmental and Public Health in the National Institute for Minamata Disease. Okay. Now, I know that maybe most of us have already heard about it, but I think we can learn more from what we will listen to from Yamamoto Sensei. So the time is yours, Sensei.
Thank you very much for your introduction. I am Megumi Yamamoto from National Institute of Minamata Disease, Japan. Thank you very much for this opportunity to talk about environmental health of mercury. This is my second visit to Jember, so I was very happy to be here again. So last time I came here 1.5 years ago, and I remember this is Agromedicine A. And last time I talked about the introduction of NMD, especially I am focusing on WHO Collaboration Center. Our institute is focusing on mercury. But this time I came here to work with Professor Tsuji and Professor Higashikubo and the Jember research team and Brin research team to work about the survey of tobacco company to occupational health workers. Last time, yes. And it's okay. And Dr. Anja visited NMD, but her face was broken, unfortunately. Oh, here. Yeah, it's okay. And last time I quickly talk about mercury, and last time already introduced, but today I'd like to talk about another topics. But at first, quickly introduce. Oh, okay.
I'm very sorry. Can we reset the screen once again? Okay. It just so happens the people there, one of them is my head, so
yeah.
I'm afraid that they will. Who is that person on the screen? Okay, hopefully the last reset will do the trick. Third time's the charm, they say.
Yes.
Okay. Let's do maybe a countdown like New Year's Eve, no? Yep, but the screen in front of us is actually okay, so maybe if what is this big thing called again? Videotron, yeah. The bigger it is, the many more pixels that can be damaged, so we have to be patient. And it's not going on. How many seconds will it take? Okay. Masih warming up. Okay, bismillah. Okay, sorry for the technical difficulty.
Yes.
Hopefully it's gonna turn on and have no more problems. I think the screen was also intrigued with the topic, so it still wanted to know the previous slides and it didn't go on. Okay, anything? Or should we continue with the, but the audience cannot see the screen, right? Belum bisa lihat. Okay, it's on. No pixels freezing. Okay, hopefully this time it will last. Okay, can we continue with the previous slide? Okay, go ahead. You
Thank
can continue.
Thank you. So, at first, let me quickly introduce mercury again. Why are people concerned about the mercury? This is because mercury may cause health effect. So today, I'd like to talk about what are mercury compounds and methyl mercury poisoning. And last time I didn't talk about it, but today I'd like to talk about the experimental studies of methyl mercury. And also exposure assessments of methyl mercury and metallic mercury, which is the most important problem in Indonesia, I think. And also exposure assessment as a tool, we developed the methyl mercury analytical method recently. That's why I'd like to talk about these topics. Mercury is around us is metallic mercury and organic mercury and inorganic mercury. These all different chemicals, different chemical structure. And this type of three mercury compound has a different toxicity. So metallic mercury has most target organs in the lung and the brain. And the methyl mercury target organ is brain. So many people are confused this toxicity and mechanisms. But in Indonesia, I think metallic mercury poisoning is one of the most prevalent recently, I think. But methyl mercury is the most famous mercury compound. It's because it will cause the methyl mercury is called the Minamata disease. That's why methyl mercury is the most famous, but in Indonesia, metallic mercury is one of the most biggest problems around mercury area. Minamata disease is a methyl mercury compound, but this is a very, very high concentration. And the methyl mercury poisoning, high concentration of mercury causes sensory disturbance, ataxia, concentrated distortion to visual field, auditory disorders. And in the adult cases, the most severe injured area is the brain. And especially occipital hole is the most injured area. That's why visual field may be injured in very high concentration methyl mercury poisoning. So in fetal Minamata disease, this is exposed in the pregnant women. In this case, injured areas all over the brain in fetal Minamata disease patient. So this is quite different from the adult cases. But in this case, Minamata is very special cases because in Minamata, methyl mercury is directly eluted from the company. And methyl mercury is poisoning directly into the sea and cause this type of poisoning. And recently, this type of severe cases is not so rare. That's why recently most important target is sensitive and exposed higher levels and sensitive population. As examples, fetus, newborn, and children is the most susceptible population. And also, this disease may cause a more severe effect. So I try to figure out the differences between diabetic mouse and the normal mouse. So target, diabetics may cause methyl mercury poisoning. It is not. So this diabetic patient may be sensitive to methyl mercury poisoning. So examination between normal mice and type B KKI mouse to compare how metabolic changes related to diabetics affects the toxicity of methyl mercury. This is a result. And the red is KKI mouse, the type 8 mouse show the more severe toxic effect compared to black 6 control mouse. So I try to why this severe effect of KKI mouse. So I determined the mercury concentration is each organs, and I determined the fat did not concentrate the mercury. This is a key, because many people think about methyl mercury is solvent in organic solvent, but this is not concentrated in the fat. So this is a conclusion. So if the same concentration methyl mercury exposure, fatty body fat did not concentrate methyl mercury, that's why blood concentration is much higher. So it may cause a health effect to more fatty, maybe more sensitive in this experiment showed. So summary is the methyl mercury layer accumulated fat, and when individuals are exposed to equal volume of methyl mercury per the body weight, the methyl mercury did not accumulate the fat, so brain and other tissue is transferred to the methyl mercury. That's why currently risk management for methyl mercury is assessed by exposure per body weight, but we have to think about other factors such as the fat component this experiment showed. And I thought, it may be very key point is distribution of methyl mercury. So I tried to one shot to diabetic mouse and normal mouse to toxicokinetics in this experiment. Let me quickly show the conclusion. To elucidate toxicokinetics of orally administered single dose methyl mercury in blood and several target organs, brain, liver, kidney, and pancreas, to compare type 2 diabetic mouse and normal mouse. So I try to use this factor. Kp value is tissue concentration per plasma concentration. This is a most useful most indicator to distribution to the body. Let me quickly show the concentration. One shot, lower concentration methyl mercury cause very quickly go to the tissue, but also quickly eluted. That's why it means that if high concentration mercury exposure, it may cause a health effect, but low concentration did not to cause a health effect, this result. That's why the So this experiment showing that high concentration methyl mercury cause a toxic effect, but low concentration did not cause a high concentration accumulation in even if they are diabetics. That's why these results indicate that even under the similar prediction to the condition, the pattern of accumulation in tissue and the effect may be different from the root exposure and concentration. So next experiment, I did the experiment using obese, pregnant mice and fetuses. So this experiment want to clarify the tissue distribution of methyl mercury in mothers and fetus following methyl mercury in obese mouse with glucose metabolism abnormalities during pregnancy. So this experiment, so take a long time. I don't want to do this experiment again, but it take a long time to exposure because feeding 4 months to control feed and high-fat diet feeding. And then we pregnant, mating, and mesomercury one shot, and to check. But this is very, very difficult experiment, but because mouse fetus very, very small, to very sacrifice to each tissue is very, very difficult. So fortunately, so we could result about established this. Fortunately, we could develop a new model for obese female mouse, and because I thought there are many research group has already produced this model, but unfortunately there are no good model for female diabetic mouse. That's why we took a long time to develop this model, but fortunately we could good model for this comparison between diabetic female mouse. So conclusion is almost similar between only one shot control mouse and diabetic mouse, almost similar for distribution to mesomercury. That's why don't worry about it. So this type of experiment is very close to the epidemiological study for exposure assessment, because as a first step, exposure assessment, how much of exposure is very important to cause health effect or not. That's why is there a possibility that mercury may cause health effect on human area where mercury concentration occurring. If exposure is mercury is high, we have to take measure and intervene to reduce exposure. But exposure is mercury is low, provide no problem. We have to say, we can say, because mercury doesn't always cause a health effect depending on the exposure situation. The health risk is not high. We have to show the inhabitants, oh, there are no problem, we can say. So I have been collaborating with Indonesian research team. So at first step, I collaborate with University of Diponegoro, and I try to figure out what level of exposure of mercury. But at that time, it's very difficult to go to the high risk group. So in this case, as a first step, we start to the real actual situation, the first step, and then we have standardized the method. We can continue to next final target to high risk group. So this is Diponegoro University published a paper about first exposure assessment of mercury in hair among pregnant women. This is the first research about the mesomercury due to the fish consumption in Indonesia. So fortunately, we could construct this protocol for exposure assessments of mesomercury in pregnant women in Indonesia. This research indicated that almost 0.78 ppm hair is a common general population in Indonesia. And, but some of the people showed a very high concentration of mercury in hair, but I think probably it may be contaminated with a skin cream containing mercury, I think probably. Let me talk about the metallic mercury contamination. This is one of the biggest problems in all over the world, where it's conducting this gold mining using metallic mercury. There are many countries where gold mining using metallic mercury, and still have a lot of problem about environmental contamination. And this is a website of UNEP. Mercury in Indonesia, it indicated is one of the most biggest mercury-related problem is ASGM. ASGM is artisanal small-scale gold mining. And I already told you before, cosmetics with mercury sometimes may cause health effect. This is a UNEP website, and ASGM related to the mercury production. Indonesia is number one. When metallic mercury is eluted to the environment, it may cause it eluted to the water environment, aquatic environment. It can be transferred to methyl mercury, and then when we take a fish, we may expose to methyl mercury. But please don't worry about it. So please eat a fish a lot. And also ASGM workers, they expose the metal mercury directly. When vapor inhalation, I think this is the biggest problem for workers. So water environment, aquatic environment, metallic mercury can be transferred to methyl mercury in the aquatic environment to can be accumulated in the human. This is my first work about mercury, 1996, because I have a question. Metallic mercury is solved in water? This is my first question. When I presented this project, my senior denied this project. Oh, metallic mercury is no problem. It is not solvable. But I was a young researcher, but I tried to this experiment, and I discovered this metallic mercury can be easily solved in seawater. This is the first work about the metallic mercury can be easily to solved in seawater. I published this paper in 1996, but still, fortunately, this paper still now, some researcher quoted this paper, fortunately. And I presented this work in Indonesia. I visited Indonesia in 1996. It's the first time. I went to the Serapong, so Indonesia. So Dr. Eka worked Serapong, so I was very happy to hear that. This is my debut of Indonesia. And a couple of years ago, I came here to the first time to survey about ASGM with Dr. Ancha, Dr. Liha from the Diponegoro University. So we went to the ASGM area at the time. And we thought this is a very highly contaminated, this area. So basically this is illegal, so it is very difficult to contact them, but I think this is a very important problem to support. Of course, we have to remember they have a life, they have to keep alive, but at least we have to take care of their health. And also, I learned from this university's agriculture medicine, so I surveyed with Dr. Ancha around this area. So downstream of SGM area, many farms there, and I think it may be contaminated by mercury of downstream. So right now I'm talking about Dr. Ancha about future collaboration about this area, how to protect this environment and agriculture downstream of the ASGM area. And also we have checked the hair of workers. So as I mentioned before, general population here mercury concentration of Indonesia is 0.7 and 0.8, but one of the workers showed 4.17. So he told me he didn't eat a fish a lot. That's why I think metallic mercury we contaminated his hair to attach. In this case, we have to separate which is caused by methyl mercury or inorganic mercury. That's why it is very important to separate the chemical form of mercury in this case. And also, I have checked the mercury concentration of tobacco. So tobacco contains obviously about concentration of mercury here. Of course, this concentration is not high to cause a health effect, but at least tobacco smoker always contaminated, exposed to mercury, and it is maybe have a synergistic effect with other factors. So Minamoto Convention mercury is always global treaty to protect human health and environment. And in this case, we have to responsible. Our institute is the Mercury Institute. We are responsible for protect human health. And the Japanese government told that we have to develop a simple method for mercury. And I have been working about the development of a new method with my former boss, Dr. Atsuhiro Nakano. And several years ago, we have published a paper about we call the NIMDB method. This can be separately total mercury and methyl mercury or using one samples. We participated in the purification test to total mercury and the methyl mercury analysis seafood. This tested, we were tested. And many research institutes participated to this test. And our code number of our institute is 50. This is a purification test result of total mercury. Center is the most accurate. And fortunately, our laboratory is most center in this test. And also, methyl mercury also center. And this is the result of total mercury, methyl mercury analyzed the same laboratory. Fortunately, our laboratory is the most closest. Center is the most accurate laboratory. And fortunately, we were most closest. Well, many research institutes involved in this test. But fortunately, we are number one accuracy. And also, we try to involved in the development of CRM, certified reference materials of blood. Of course, we don't know the concentration, but final result showing that this method was most accurate for even if the sample was blood. And many research institutes come to our institute. And for example, Jember University and the DePaul University and other countries, so many researchers come to learn how to analyze mercury. And Petri and many. Petri have organized a couple of years ago, she presenter, right? And also they learn how to do mercury analysis in my lab. Every year, some students from Indonesia come to my lab to learn how to analyze mercury. This is a very important tool for exposure assessment. This is Zara. Last year, she came here. And in last month, researchers from Ghana and Brazil come to my lab and to learn how to do this analytical method. And they have a same problem in Indonesia. There are severe metallic mercury pollution in Ghana and Brazil. And they told me the downstream of ASGM and agriculture was heavily contaminated. So they were worried about it. That's why mercury does not always cause health effect depending on the mercury exposure situation, but exposure assessment is very important to the first step to protect human health. So it's important to exposure and risk assessment carefully to proper understanding of hazard and risk. If there are possible health effects due to mercury, we will try to prevent them. And a low possibility, we can say, oh, you don't need to worry about it. It is very important. I think. So here is a collaborator. So Professor Tsuji has been, and the Indonesian research team, we have been collaborating with them, and we have a very good result. And recently, I have another job in the weekend. I work about the Kumamoto Prefectural Center of Environmental Education Intelligence. This center is focusing on how environment protection is very important. So sometimes I went there to accept many young generation to learn how to protect very important. Minamata Bay was formerly the bay, but recently this is a protected, this park, but formerly this is a bay. Japanese government have a high amount of money to recover this environment still now. So we try to continue to work with Indonesia because I have a very good impression to research from Indonesia. I have accepted many students from Indonesia and very good communicate with them. So we hope to continue to environmental health of not only mercury but also other factors. We'd like to continue to work with you. Thank you very much.
Thank you very much. I think we can just be seated for the next session for the question and answer. I would like to also invite Tsuji Sensei and Higashikubo Sensei to the front because we will be going on to our segment. I think this is what the participants here are waiting for. Hopefully they will would want to ask more questions about your topics. So three very exciting topics, some that we can relate with and some that might need more digging in, and hopefully because these are their expertise, we would like the audience here to state your name first. So introduce yourself and where you're from, and then state who you address the questions to. Okay, so we will accept questions from the audience. I hope it's okay with you. Who would like to ask first? You can raise your hand and I will call you out. Okay. Oh, we have so many. Okay, we'll start with the gentleman in the front. Okay, please.
Check. Should I stand up?
Yes, you can stand up so we can see you better. Okay.
So, good morning, ladies and gentlemen. My name is Yopi from Faculty of Nursing, Universitas Jember. Thank you so much for your insightful presentations. Quite new knowledge for me as a nurse to hear regarding your three best research regarding the occupational health and environment. My question is to all the speakers: how to make your research to become how to make your result to become the translational research that, as we know, translational research is bench to bedside research. How far the researchers can inform your results regarding the chemical things to the other sectors such as government and also farmer, because in Jember we have one program that's called agro-industrial sectors, and how to implement your research to the farmers, to government, to the villagers regarding the dangerous thing about the chemical. Thank you so much.
Okay, would you like to answer before we forget the question, and then we continue to the next one? Who would like to give? So the question was about how would you implement the research from your topics to the government. Yeah, you can use this one.
Thank you very much. Important questions. Let me answer about from the viewpoint of mercury, because when I visited here for the first time, here is a very, very important agricultural medicine. So from the viewpoint I mentioned before, so our institute is a government. That's why not only focusing basic research. We have always think about how to transfer this information to people and how to protect the human health from the viewpoint of the government. Especially, Minamata is a very, very sensitive problem in Japan, so we'd like to transfer this type of similar bad situation to other countries. So for example, I talked before, right now I'm thinking about the collaboration with Dr. Ancha and Dr. Diponegoro University, because recently, after I finished this seminar, I will go to the Diponegoro to set up the mercury analysis systems. So we collect this downstream of the agriculture. So we collect this, for example, the plant to determine the mercury contamination in Diponegoro. It may cause caution, so it obviously contamination. That's why please protect so environment. Please don't elute this metallic mercury. But we have to also think about their life. This is illegal, but they have to keep their life. That's why it is very important to transfer this information to inhabitants and workers, and we have to think about our both.
Would you like to add something, Suji Sensei?
So from my viewpoint, if I do my survey in agriculture area, so there are a lot of chemicals in agriculture areas, so pesticide and some chemicals, and for view of allergies, a lot of allergen is in agriculture area. So I'm not a government people, I'm a university researcher, so I'd like to do the epidemiological study in agriculture area and take some result and make paper and access the government. So a researcher only can do is make a lot of evidence from result. So of course I am a JX member, so I have a connection to Japanese environmental ministry. So I directly sometimes talk with them. But it's, yeah, I know it's very difficult, but anyway, I try. Sorry, it's not my good answer, but sorry.
Yes, thank you, Suji Sensei.
Yeah,
Would you like to
Higashikuro
add?
Sensei is he's an industrial researcher, so he don't have agricultural exposure
Oh, I see.
viewpoint.
Oh, okay. No, that's fine. Okay, from Suji Sensei's and Yamamoto Sensei's answer, was it enough for you?
Yes,
Yes.
thank you so much.
Okay, thank you so much. Okay, we will continue to the next question. I think there was somebody over there. Oh, okay. Is it enough? Yes. Okay. Just state your name again, dear.
Okay, thank you so much. Good afternoon, everyone. And I would like to say thank you to all the speakers for delivering a very brilliant topic. So, my name is Dinafti. I'm a second-year student of Faculty of Medicine, University of Jember. So, my question is especially for Professor Ichiro. So, I'm really amazed of the Japanese government of the occupational health management. So, they really care about the workers' well-being in the company. So, I'm curious about so far, my exposure about the Japan is workaholic. So I would like to ask, is it a personal interest to be a workaholic, or is it an obligation to live a life in Japan? And because of the workaholic characteristic, I feel like it means that the stress level in the Japanese worker is high. So I'm curious about, is there any special regulation about the well-being of the mental health of the workers? Does it have maybe a consultant team to make sure that the workers is in a good condition? Because it is, I think, related to the
work management area? And that's my question. Thank you.
Okay. Okay, let me repeat the question again for Higashigubo Sensei. So the student would like to know whether, because I think the characteristic of the workers are
maybe
tough.
she wants
Is
to
there
know
any
mental health
mental
in
health?
Japanese. Is it okay?
Yeah. Is
Oh,
there
so-
any
yeah.
management for that for
Management
those who
for
have high stress
Yes.
environment?
So I'm industrial physician too, and occupational environmental health make a lot of industrial physician every year. So Japanese workers are very workaholic. So they feel stress every day. So now 5 years ago, I'm forgetting the stress check. Stress check is started in Japan by law. So stress check, we all workers answer the question: do you feel stress? What is a stress? What is causes? What is your source of stress? So our physician check that result, but company don't know who answers the question. Because if the company know, he complain about our company, so it's not bad. So nobody, only physician knows who write the questionnaire. So we advise the company, your section, the workers feel a lot of stress by not communication between supervisor and workers, juniors. And so work time is so long, so they feeling very stressed. So please go home quickly, we advise. And some person want to discuss with industrial physician, so we talk about 30 minutes why you are feeling stress, which is the most best way to reduce your stress. And sometimes we advise you must go to hospital because you need medicine and more. So yes, Japanese government gradually progress to workers' stress, but still progressing now. So sorry, not so good answer, but anyway, try. We are.
Yeah, but I think we get the gist about it. Higashigubo Sensei, would you like to add a little?
Okay, so. So Japanese, many workers feel stress, so the number of suicide for workplace reason is higher than car accidents now. So yeah, it's a terrible problem. So government check the 1 3 work hours.
6 hours.
So,
Okay.
and Higashiko Sensei is a 作業環境測定士 measurement the environment in factory, so the light and weight and temperature is very important for workers. So such kind of researcher checks the factory's environment, and we try to keep the comfortable environment and environment. That's all. Sorry.
Yeah, so the working environment does affect workers, right?
Yes.
But I think another interesting point about the question is, even though there's, for example, there's a way of managing, sometimes we also, we can also, like, not predict, but maybe in some cases, people with certain work environments are already accustomed, or it's already a habit. In the beginning it can be stressful, but at the end it's like, oh yeah, this is my working environment and everything's okay. They get accustomed to it, and when that happens, the stress level may be lower. But yeah, as you said, if the suicide rate is sometimes high for certain individuals, is there any prevention measures in the management, in working management in Japan?
For prevent suicide.
Yeah. Is there any?
Yes. So working to check the work hour time.
The work hours.
Yes,
to
work hour
be
time.
honest.
And every
I see.
year we take a health check. It is
A
a
health
company's law. And
Every year.
yeah,
Annually.
50, the company has an industrial physician. So
I see,
yes, we try to check workers as possible as we can. Yeah.
Yeah, hopefully the screening will not find too many people who are stressed out. Okay. Does that answer your question?
Yes, thank you very much.
Okay, thank you. Yes. Okay, I think we still have time around 10 minutes if there's any other questions, maybe from this. Okay, go ahead. We have another student here. She will state your name first, okay?
First of all, thank you for this opportunity. I am Avicenna third year medical student in Universitas Jember. I have two questions, both of Yamamoto sensei, Suji sensei, to Higashikubo sensei. The first one is for Yamamoto sensei to Suji sensei. The first one is there a possibility for some chemical structure in future that can reduce reaction or toxicity of manganese or mercury, even methyl mercury, metallic mercury on or inorganic mercury? And then the second question for Higashikubo sensei, what is the minimum standard of the working environment management? As you said before, there are design, sampling analysis, and evaluation. If we do research in some place that cannot give the facility as the normal standard, is there a tolerance for the minimum standard of this one? Thank you.
Okay, thank you very much, dear. Okay, the first question, was it already clear for you? Yeah, I'll confirm. So she wanted to ask whether it's possible to reduce the toxicity of mercury and manganese in the
Yes.
future?
Yes, with some other chemical substances.
Substance and others.
Yes.
Okay. First?
I think, yeah, to be honest with you, we are talking together. One of the problem may be due to the pesticide. So today we finish this seminar. We will discuss with the researcher from University of Jember and Berlin about how to manage the control of the health effect of pesticide, not only heavy metals, but also pesticide may be a problem here.
Would you like to add something, Suji sensei?
So yeah, Yamamoto sensei already said, so in your country, maybe pesticide is a very severe problem, because I think pesticide is a very, I think, stable, so it is difficult to disappear from the world. So the effect of pesticides have been long. It's a very problem. So in Japan, recently P4, some new chemicals is now growing problem. So there are maybe 1,000 new chemicals is import in Japan. So we very difficult to catch up with. So Japanese government, before 3 years ago, our industry physician and the company and the government try to check how to use the chemical. But every year a new chemical is born in the world. So Japanese government said, please check the chemicals effect in the company by themselves. So to treat chemicals is a very difficult problem, but anyway, researchers try to continue most dangerous chemicals and target and continue the research is necessary. I think so.
I forget to tell you. I think air pollution is a big problem because I attend this WHO meeting. Japan is belong to UPRO, Western Pacific Region Office, and I attend the meeting, and everybody agreed to protect air pollution, and lung cancer or maybe many diseases may cause from the air pollution. To be honest with you, I went to Hanoi and Jakarta. I surprised to air is very foggy. When I grown up in Japan, Osaka is a big city, and Kitakyushu a big city. And when I was a kid, many air as a smoggy, and the ground is many contaminated. Recently, very clear. But I went to Hanoi and Jakarta, many foggy, and car is very traffic is very crowded. So WHO recognized air pollution is very big problem, I think.
Maybe better is not old problem. I think so. So Japan and Indonesia has volcanoes. I think some area has high metal area. Maybe there are some high metal area. I think so because Japanese too. So volcano release a lot of chemicals, of course, metals too. So metal is not old problem, I think. Yeah. How about you? So Mr. Higashikubo Sensei said, every chemical has toxicity, weak or high, is depending on chemicals. So the user use very widely, and
Use wise. Yes, you have to use these things to lower the exposure, right? Okay. And I think there was one question about you were talking about the working management in Japan. What is the minimum requirement of for example, for a factory to have when they are managing the working measurement system? Is there anything minimum requirement for it in the facility that has to have minimum requirement? The minimum requirement for the working. I'm sorry. What was my? Yeah, the working to do the measurement in the working area. Is there a minimum requirement that has to be put in a factory, for example, that is already established in Japan? Is that the question? Am I correct, or would you like to redirect the question? Is that correct? Okay. Would you like to have? Yeah, the minimal requirement of in a factory to be able to do the measurement correctly.
Yes. So Japanese environmental measurement is decided by law. So we have to check 6 months. Twice.
Twice a year.
Year.
Okay, every 6
so
months.
If the environmental measurement data was bad, so government order, please change the environment environment.
Will there be an intervention from the environment if they find intervention from the government if they find something in those findings? Oh, okay.
Yes.
So every 6 months they would check the
Every 6
working
months.
environment.
Yes.
So any factory that has workers and have a risk in the working environment, they have to check annual for the workers.
Yes, only
An
1
annual too.
year's health check is all workers take.
Okay.
And twice a year environmental
Twice
check
a year.
is under the
Environmental
law.
check too.
Yeah, and the person who using special chemicals that have a strong toxicity, maybe twice a year they check the health. Yeah, check health.
The more
Take
dangerous,
blood.
the more
Yeah.
assessment will be
Yes.
done. Okay, I think that kind of makes sense. Does it answer your question adequately? Okay. Let me check the time frame that we have. It's already 50 minutes after 2. Just let me check around. Is there any other, maybe one last question before we end, if there is any? Let me see. Or was it already questioned by the 3 previous people? Yeah? Okay, I think we know that all of your topics are actually interrelated, although one was talking about the working measurement, the other was talking about mercury, and the other was talking about the risks in welding up workers who weld. All of them are actually in the agro-industrial department. So I think what these 3 speakers have given to us today is actually an enrichment or more enlightening to how we should, it's our own perspective to make sure that these workers have a better condition. Their well-being is also our responsibility. And let me highlight the 3 topics for today to make sure that we take home the same message, because sometimes we can get overwhelmed with what people say, and hopefully with my little wrap up we will conclude these 3 topics today. So the first one was about the working measurement. We understand that workers have a high they have a high responsibility in doing their jobs, but it's also the factory's responsibility to be able to do the assessment. And maybe from Hikashi Kubo's research, it's important to know how to put the location sites and assess the area that has most risks. And from Suji Sensei's topic today, we also learned that because we also have welders in different fields, and in a small moment we can see that it's a high risk job, right? I mean, you doing about that close exposure with the welding part. I mean, we know that the danger of welder workers are real. And as you said, you actually stated there are 2 major, the most high risk is the manganese and the plastic resin. Is that correct? Yeah, and I think there are other chemicals too, but I think those 2 were the ones that were investigated today in the research that has been done. Yeah, hopefully if we are aware of what the risk hazards are, we will try to minimize. And you said the most important part is to wear those protective masks. And we know here that not only in welders, maybe tomorrow when you see the tobacco factory, you will see that I can't even say how many %, but the majority do not wear masks, although they are exposed to a lot of dust from the tobacco. And last but not least, from Yamamoto Sensei, because he has been here last year, but this time he actually mentioned about the toxicology of mercury, and we've heard about the adverse effects of mercury, but I think there was one statement that we can be a little bit relieved. So actually mercury does not always have health effects. It really depends on the maybe position, the duration of the exposure, etc. So if we know that we are exposed to high risk mercury contents, then we should be aware, and we should check ourselves up, something like that. Okay, so once again, I would like to extend a great gratitude for the 3 professors today, Yamamoto Sensei, Suji Sensei, and Kashikubu. I hope that we can continue our discussions in maybe future collaborations, although maybe not in this discussion today, but in future discussions. And for me, myself, I would like to apologize if there are any shortcomings, and sorry for the technical difficulties before. And I think this guest lecture has actually enlightened also me, as I'm also in the public health department, and there are so many aspects of public health. So when we hear about all these problems, it's like, oh, this world there's, I think, is the problem more than the solution? Well, let's try to find the solution together. Okay, so everybody, thank you very much for attending today's guest lecture. Let's give a round of applause for 3 great experts today. And I would like to close the sessions, and everybody have a nice day. Assalamualaikum warahmatullahi wabarakatuh. Okay, I return the session to the MC. Zahra, go ahead.
Okay, thank you so much
here?
for Dr. Dita for guiding
you
us
stay?
today's valuable session. So, yeah. After this, we will continue to the presentation of the certificate for all the keynote speakers. You may come back, Sensei. Sorry.
Yeah, we will give the certificates for each and
Yeah,
every one of
presented
you.
by our head division of academic, Dr. Al Munawir. Starting from Higashikubo Sensei. And for the documentation team, please help to capture this. And the second for Suji Sensei. For Yamamoto Sensei. And last but not least, for our moderator today, Dr. Drita. And Sensei, please, we would like to take picture together with the audience. Yeah, you may come forward to the center. Yes, and for the audience to stand up, everyone, we will take a picture together. Okay, on my count. Everyone's ready? Okay, Ichi, ni, san. Moichido. Okay. Agromedicine. Thank you. You may now be seated back. Okay, before we close, a reminder to all participants, please fill out the attendance form, access at this and the certificate link using the link provided on the screen and in the chat box. You can scan the QR code to receive your certificate of participation. And to conclude, today's lectures have highlighted the importance of integrating occupational health, environmental monitoring, and rural industry safety. This collaboration is vital to protecting workers and communities in agricultural areas. And on behalf of the Faculty of Medicine, University of Jember, and the organizing committee, thank you so much for your engagement. We hope you all live inspired to apply this insight in your work and your studies. And as your MC, it is an honor for you and for me to accompany you during this session. So, domo arigatou gozaimashita. Thank you so much.